Okay, hello everybody. This is videos about inequalities in one triangle, which we'll get to pretty quickly here. But we got to talk about a new type of proof that we have not had yet this year. We've had a two-column proof. That's one style of proof, and we've also had coordinate proofs. So this is yet another type. And the goal of all proof is just to prove or to show something is true based on knowledge and facts and reasoning. So we started with this year with a direct proof, which is the two-column proof. That's when you begin with a true hypothesis or something that's given to you. Then you reason step by step, and remember in a two-column proof we showed statements and gave a reason for each statement. So we were building a logical argument which eventually would lead to the conclusion, which is what we were trying to prove. That's a direct proof. It's normally written as a two-column proof. Today we're going to look at indirect proof, which is quite a bit different, but still kind of more or less common sense and understandable. Indirect proof is when you try to prove something, you actually assume the opposite of what you're trying to prove is true, which sounds strange. Start by assuming the opposite of what you're trying to prove is true, and then reason logically, step by step, until you arrive at a contradiction. And so when you arrive at that contradiction, the only thing that could be false was your original assumption. And so that would show you that your original assumption is false and what you're trying to prove is actually true. Okay, so that's a lot to think about, and I'll do an example of that here pretty quick. So let me summarize the steps to writing an indirect proof. It's 4 steps, really. Identify what you're trying to prove. What are you trying to prove? That's your conjecture. After you've identified your conjecture, assume the opposite or the negation of that conclusion. Assume the opposite is true. Just say, you know what? Let's just say the opposite of that is true, just for instance. Let's just say that. Then use your direct reasoning. Use all your theorems, postulates, definitions, whatever you have, and keep on reasoning, starting with your assumption. At some point, you will arrive at a contradiction, something that contradicts something you know to be true. And so in the process of your thinking, once you arrive at that contradiction, the only flaw in your argument was your original assumption. And so your conclusion is that your assumption is false and that what you really are trying to prove is true. Okay, so that might be a lot to think about. Let's see how that works in action. Okay, so I'm going to make an indirect proof argument here. So you see in the diagram a right triangle LJK. So we want to write an indirect proof that a right triangle cannot have an obtuse angle. Remember, an obtuse angle is an angle greater than 90. So what we would do is we would assume the opposite of what we're trying to prove. Assume a right triangle can have an obtuse angle. So assume a right triangle can have an obtuse angle. So you're assuming the opposite of what you're trying to prove. Okay, let's just talk about it. So if that right triangle has an obtuse angle, that means it has one angle which is 90 and an angle which is bigger than 90. Right? So if you have an angle that's 90 plus an angle that's bigger than 90, your degrees, not even in thinking about that third angle, is already bigger than 180. Okay, so that's going to contradict the angle sum theorem. That's going to contradict the fact that an angle sum of a triangle is 180. So we arrived at a contradiction of a theorem that we already know to be true. And so the only flaw in our argument there was our original assumption. We assumed that a triangle can have an obtuse angle. We went with that. We showed that that contradicted something we already knew to be true. And so our assumption is false. So we would say in our proof, I didn't write everything, but our assumption is false. And so it must be true that a right triangle cannot have an obtuse angle because we assumed it could. That led us to a problem, a contradiction, and so our assumption was false, and it must be true that a right triangle cannot have an obtuse angle. So that's just another style of proof. It's another way to show that something is true. Just a different technique. Okay, so here's what we're really talking about today. And so we need to know the following about a triangle, about its angle-side relationships. So here's what we have here, and we're not going to prove this. I'm just going to give this to you, and you just got to be able to work with it. So in a triangle, the longest side is always across from the largest angle. The middle side in length is always opposite the middle angle in degrees. And the shortest side of a triangle is always across from or opposite the smallest angle. So for example, let's look at this triangle that I have right here. Triangle GJH, and you see the side lengths given there. So the directions say write the angles in order from smallest to largest. So if I want to write the smallest angle first, I will locate the shortest side. Well, the shortest side out of that triangle is the one that says 27.2. You can see it's side GJ there, 27.2. So that means the smallest angle in that triangle is angle H. We don't know how many degrees it is, but it's going to have the least number of degrees, angle H. Okay, now let's find the middle side in length. That'd be the 28.5, wouldn't it? So the middle side is 28.5. That means angle J, which is across from that side, is the middle angle. Okay, now let's find the largest angle. Well, if you want to find the largest angle, you got to find the longest side first. So the longest side there is 33.4. That's across from angle G, so angle G will be the largest angle. That's all you got to do. Just understand that the longest side is across from the greatest angle, the middle side is across from the middle angle, and the shortest side is across from the smallest angle. Easy to remember that. Okay. Now let's do a kind of a variation on that problem. But before we do that, let's find angle M. So we're going to take 39 plus 54 equals 93. All right, so those two angles add up to 93. So then we'll take 180 minus 93. It's going to give you 87 degrees. So we now know this angle is 87 degrees. Okay, now we can write the sides in order from shortest to longest. So you want the shortest side, find the smallest angle. Smallest angle is 39 degrees, so the shortest side is across from that, so that'd be Km. So Km is the shortest side of that triangle. What's the middle side? Well, find the middle angle. The middle angle is 54 degrees, angle K. So the middle side is across from that, Lm. You want to find the longest side, then find the biggest angle. The biggest angle is 87 degrees, so the side opposite that is Lk. So we just wrote the sides in order from the shortest to the longest, based on the angles. Okay, that should be easy enough. Okay, triangle inequality theorem. We're going to use this quite a bit. The triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if you have a triangle with some sides given, whatever they are. I'll look at example A here. I'm not going to quite make that a triangle yet. But in any triangle that you think about, if you take up any two sides and add them together, that must be greater than the third side. So to kind of put a visual with that, let's say I take the sides 3, 5, and 7. Now, just because I would write them on the sides doesn't mean that I have a triangle. So let's say this side is 7, this is 5, this one's 3. Would that actually make a triangle? Well, if you think about this, if the 5 and the 3, maybe that were like a 2 and a 3. Well, they wouldn't even come together, would they, if that was a 2 and a 3? They wouldn't even come together because this bottom side is 7. But if you can see that the 5 and the 3, which add up to 8, is greater than the third side, then you certainly do have a triangle. So you can go ahead and draw that in there. So again, the triangle inequality theorem says if you just pick any two sides of that triangle, whether it's the 3 and the 5, that's got to be bigger than the 7. The 5 and the 7 got to add up to be bigger than the 3. And the 3 and the 7 got to add up to be bigger than the 5. If you take any two sides of that triangle and add them together, that must be greater than the third side. Otherwise, your triangle will not come together. It will not form a triangle. So, short answer to this one is yes, those form a triangle. And really, you don't have to check every possible combination. Just check the smallest two, the 3 and the 5. Does that sum greater than the third side? Yes. So that is a triangle. Let's try that one more time. Let's say this time we have a triangle with sides of 4, 6.5, and 7. I'll put that 4, 6.5, and 11. I'm going to put that 11 on this side. And let's say these other two sides are the 4 and the 6.5. Do you kind of see intuitively that if you folded these two sides of the triangle down, they wouldn't touch, would they? If you folded them, because 4 plus 6.5 is 10.5, they wouldn't touch because they're not greater than 11. If they are equal, let's say one of these was 6 and one was 5, so that the two other sides equaled the third side 11, then they would collapse into a straight line segment. You would not have a triangle. So the triangle inequality theorem says that any two sides, the sum has to be strictly greater than the third side. So this is a no. This is not a triangle. Just because you write three, just because you could draw this all you want and make it look like a triangle. It's not a triangle because two of the sides are not greater than the third side. I mean, if you chose 11 and 6.5, that's true. Those added together greater than 4, but it's got to be true for every pair of numbers. So if you take the two smallest numbers, that's how you check it. You take the two smallest numbers out of 3 and add them together. Are they greater than the third number? If so, then you have a triangle. If not, you do not have a triangle. That's the triangle inequality theorem. Okay. Here's another example I want to go through. And this one, let me look ahead a bit here. What we've got to come up. I guess that's our last one. Okay. It's our last example. Yeah, so the length of two sides of a triangle are 6 and 11. Find the range of possible lengths for the third side. Okay, so to do this, we're going to set up 3 inequalities. Let's say that the sides are 6, 11, and let's just call this side S. We don't know it. So what could S be and still have a triangle? Well, we're going to set up 3 inequality statements. So we'll say 6 plus 11 is greater than S. 6 plus S is greater than 11. Remember, any two the sum's got to be bigger than the third one. And then S plus 11, I had to make sure I get that right. S plus 11, it's got to be greater than 6. Okay, so they're going to give you two sides. You just put your third side as a variable and then write 3 inequalities and then solve them. So here we have 17 is greater than S. Here we have S is greater than 5. And here we have S is greater than negative 5. Okay, let's kind of put these together and then see what could S be. What's the range of numbers that S could be? Okay, well, this one, remember, this really, 17 is greater than S. That means S is less than 17. So you can rewrite that like that. So it looks like S has to be less than 17. Okay. Now, if you take these two together, these two greater thans together, oops, you don't want to see that little line through there. Maybe I can make that go away. Let me try it. Went away. Good. Okay. If you take those two together, if a number is greater than 5, it's automatically greater than -5. So we can toss that out and just put these two together. So your side, that third side of that triangle, must be less than 17 and says greater than 5. So we can say 5 is less than S is less than 17. So the range of sides for that third side, the range of numbers for that third side of the triangle, that third side of the triangle must be between 5 and 17. Not equal, not greater than 17, not less than 5, and not equal to either number. So it's got to be strictly between 5 and 17, that third side of the triangle. Okay, so that's all the information you need then to work on your assignment. Let me do a quick review of what we talked about. We talked about an indirect proof, which is a new way of proving something where you assume the opposite of what you're trying to prove is true, and then reason logically step by step until you arrive at a contradiction. And then your conclusion is that your original assumption is false and that what you're trying to prove is actually true. We also then talked about the angle side relationship, that easy to remember. Longest side across from greatest angle, middle side is across from middle angle, smallest side is across from smallest angle. So that's important to know that. And then we ended up with the triangle inequality theorem that says if you take any two sides of a triangle and add them up, that must be greater than the third side. Otherwise, you won't have a triangle. Okay, there you have it. Enjoy. Let's get some practice with the assignment.